Okay, so there are two purposes of today's lesson. One, mathematically, our goal is um, to introduce our first unit, which is on sequences, and then our second goal is, from a housekeeping standpoint, is to model what a typical lesson will be like in my class. You might remember if you took Algebra 1 or you took geometry here, um, the layout of the lessons will be very similar, with a couple of minor differences. So as you saw, as you just did, every day a PowerPoint will be shared with you ahead of time on Google Classroom. Make sure you always complete the virtual attendance form as soon as you get here and open it up on your computer. That's how I'm going to track attendance every day. There'll be a warm-up, which we already did, and there'll be lesson notes, which you should have copied down already. And then after we go over the warm-up, then I will share with you a video, the video you're watching now, in which I talk about the lesson notes and then go through the examples that follow. So today's lesson notes, you can see, is nothing too earth-shattering. Our first unit is on sequences. A sequence, as we talked about yesterday with the pre-assessment, is simply a pattern of numbers, a list or a pattern of numbers. One of the things we talked about in the pre-assessment are the different ways you can represent a sequence. There were a couple of examples. You might remember the bus example, where we had to create a graph. So a graph is one way to represent a sequence. Another way to talk about or describe a sequence is to talk about each term and relate it to the previous term. So you can see here, it's a very silly example, but we have a term in which we're going up by 2 every time. So our starting term is 3. Remember, we talked about how the first term of a sequence is referred to as term 0. So our first term, our starting term, our term 0 is 3. And then we to get the other terms, the following term is 2 more than the previous one. So we add 2 to whatever the previous one is to get each of the successive terms. So that's how we relate one term of a sequence to the next. We talk about where we start, what our starting term is, and then how we get each of the other terms. In this case, we started at 3, and we add 2 to the previous term to get all the other ones. Okay, that's the lesson notes today. That's it. So then after I talk about the lesson notes in the video, I'll then go through the examples that follow on the PowerPoint. I'm going to do that here. So let's look at example number 1. That's the wrong one. Here we go. So here is a rule to make a list of numbers. Each number is the sum of the previous 2 numbers. Start with the numbers 0 and 1. Then follow the rule to build a sequence of 10 numbers. So we're starting with 0 and 1, and then each successive term is going to be the sum of the previous 2. So the third term is going to be 0 plus 1, which is 1. The fourth term is going to be 1 plus 1, which is 2. And we're just going to continue that until we have a list of 10 numbers. So the fifth term is going to be 1 plus 2. So that's 3. The sixth term is going to be 2 plus 3. The seventh term is going to be 3 plus 5. And 1, 2, 3, 4, 5, 6, 7. So we need 3 more. The eighth term is going to be 8 plus 5. The ninth term is going to be 13 plus 8. And then the 10th term is going to be 13 plus 21. So 13 plus 21 is 34. And this is our list or sequence of 10 numbers here. Okay, so that's example number 1. Example number 2, a sequence starts 1/2, 1/4, 1/8. Okay. Give a rule that the sequence could follow. Now, you'll notice it looks like we're multiplying the numerators or the denominators by 2, but the numerators are staying the same. So the numerators are staying the same. The denominators are being multiplied by 2. Another way to describe it mathematically is to multiply each term by a half. Okay, a half times a half is a fourth. 1 times 1 is 1. 2 times 2 is 4. Okay, same thing here. A fourth times a half is equal to an eighth. 1 times 1 is 1. 4 times 2 is 8. So give a rule that the sequence could follow. Okay. So we start at 1/2. Okay, that's the first part of the rule. And then multiply the previous term by 1/2. Okay, half times a half is a fourth times a fourth, or fourth times a half is an eighth. Okay. Follow your rule to write the next 3 terms of the sequence. So our first 3 terms are a half, a fourth, an eighth. And then to write the next 3 terms, again, we're going to keep multiplying by a half. So an eighth times a half is going to be 1/16. Then we'll go to 1/32. Okay, 1 times 1 is 1. 16 times 2 is 32. And then 6th term, 1 times 1 is 1. 32 times 2 is 64. So 1/32 times a half is 1/64. Excuse me. So that is the next 3 terms of the sequence, and that is it for example number 2. Okay. Example number 3. Okay. A sequence of numbers follows the rule: multiply the previous number by -2 and add 3. The first term of the sequence is -7. Okay. Give the next 3 terms of the sequence. So to find the next term, we're going to multiply the previous number by -2. So -7 times -2 is +14. And then add 3. So the next term is 17. Okay. The next term, we're going to take the previous term, multiply it by -2. So 17 times -2. Okay, that's going to be -34. Use a calculator if you need to. And then add 3. -34 plus 3 is going to be -31. Okay, so that's the next term. And then we have to do one more. So take the previous term, multiply it by -2. So here we have a negative times a negative. -31 times -2. That's going to be +62. Plus 3 is 65. Okay. And that is it for example number 3. Okay. And then the last kind of example I have for you today, if we go back to the PowerPoint here, okay, and go to the next slide, I have a bit of a challenge game. Some of you might have played this game before. but it's called the Tower of Hanoi puzzle. It involves taking a disk and moving it to another peg. There are only two rules. Okay, you can only move one disk at a time, and you can never put a larger disk on top of a smaller one. You can only put small on top of large. Okay. Complete the puzzle by building the complete tower on a different peg other than the starting peg. So I have an example right here. You would have to, the game would be considered solved or complete when you've taken this setup and replicated it on one of the other two pegs. So I'll give you an example. Okay. Here we have one with two disks. And if I wanted to duplicate it, I might take this one and I'll move it over here. And I'll take this one, I'll move it over here, and then move this one on top of this one. And notice it says I solved it in 3 moves. Okay. The goal, the challenge for this game is to solve it in the least number of moves possible. Okay. And we want to think about what patterns you notice. So what I would like you all to do is to pause this video and play around with this puzzle. Okay. I just solved it with 2 disks for you. I want you to try it with 3 disks. I want you to try it with 4 disks. And if you really want to challenge yourself, try it with 5 disks and see if you can solve it and track the number of moves it takes and see if you notice a pattern. So pause this video, play around with this game, and then come back to this video. Okay. So let's take a look at the patterns we noticed. So we are looking at the number of disks versus the number of moves it takes. And we want to be able to solve it in the least number of moves possible. So obviously, if I only have 1 disk, it's only going to take 1 move. Okay. And we saw before, when I did it with 2 disks, it took 3 moves. Okay. And what I ask you to do is to try it with 3 and 4 and maybe 5 and see if you can solve it. Okay. Now, if you did it correctly, you can solve it with 3 disks in as little as 7 moves. Maybe you took more than 7, but that is the least you can do with 7. With 4 disks, the least number of moves you can do it in is 15. Okay. And with 5 disks, if you really challenge yourself, the least number of moves you could do it in is 31. Okay. And what I ask you to do is notice any patterns between the number of moves. And if you look at it, hopefully you notice that we start at 1 and each number after that is double the previous plus 1. Okay? 1 more than double. So double 1, 1 times 2 is 2 plus 1 is 3. If I do the same thing here, 3 times 2 is 6 plus 1 is 7. 7 times 2 is 14 plus 1 is 15. 15 times 2 is 30 plus 1 is 31. So I could predict that with 6 disks, I could solve it in as little as, let's see, 31 times 2 is 62, plus 1 is 63, so on and so forth. So the pattern is double the previous plus 1. Double the previous plus 1. Okay. And that is your lesson for today. Now, as I said earlier, in the comments section on Google Classroom, Okay. I shared with you the cool down. You might remember doing cool downs in geometry and algebra 1. There'll be a cool down for every lesson. And what I would like you to do is to do the cool down right in your notes. Do the cool down in your notes. Take a picture of the cool down with your phone or the webcam or the camera on your computer and email me the picture. That is how you're going to submit your cool downs to me this year. There will be no handing in papers. There will be no paper assignments. Everything will be posted here. And that is how I would like you to submit them. Do it in your notes, take a picture, email me the picture. And that is how I will track the assignments that you're handing in.